Okay, in this video, we are going to look at how we use the chain rule to find the derivative of a function. So let's start with the instances where we use the chain rule. So recall that when you have two functions that are composed, so we might say f of g of x, which means that we're using the function g of x as the input into the function f. And the question is, how do I find the derivative of this? So recall that we said that if we want the derivative of this function here, f of g of x, then we're going to take the derivative of the outer function evaluated at the inner function times the derivative of the inner function. And this is really a place where I find that most students struggle with the chain rule, and it's right here. What they want to do is they want to put the derivative of g in here into the derivative of f. But that's not how the chain rule works. So we're going to look at a few examples to show how this comes about. Okay, so let's look at the function f of x equals e to the sine of x. Okay. Now, one of the things that you need to kind of keep in mind is, what is this the composition of? This is the composition of two functions. First, e to the x, and second, sine of x. So in essence, I am putting sine of x into the function e to the x. So when I go to look at the derivative of f, according to the chain rule, I'm going to take the derivative of the outside. Now, the outside function in this example is e, right? So the derivative of e to anything is e to that thing. And so remember, we leave the g of x alone, so it's going to be times sine of x. As the exponent will be sine of x. Then we multiply by the derivative of what's up top, and that is cosine of x. So that would be the derivative of e to the sine of x. Let's do another one. F of x equals cosine of x squared plus 2. All right, now this one's a little easier to see what are the inside and outside. The inside function is x squared plus 2, and the outside function is cosine. So when we go to do the derivative, we're going to have the derivative of the outside, which is negative sine. And this is where, again, a lot of times it's easy to make a mistake. We leave this alone. This is evaluated at x squared plus 2. Then we multiply by, and note here that I'm going to put this in parentheses. This will be 2x. And it didn't matter on this one, but it could have mattered if we had had something else, because you've got to multiply the entire thing. And so we'll look at an example like that here in a moment. Okay, so let's do one that's a little bit more involved. This next one is going to involve both the product rule and the quotient rule. So let's suppose we had f of x equals, let's see here, let's try x cubed tan of e to the 2x. Okay. So first off, note that you have the product of two functions. So I've got to use the product rule. All right. However, when I get to the derivative of the second function, it is the composition of two functions, so I'm going to have to use the chain rule. All right, so the product rule tells us that we're going to take the derivative of the first, which is 3x squared, times the second, plus the first times the derivative of the second. So now I need the derivative of tangent of e to the 2x. Now notice, this is a composition, so I'm going to have to do the derivative of the inside, the derivative of the outside, which is secant squared, and I leave the inside alone. And then times, now this is where it's important here, and I'm going to go ahead and put parentheses. Now I got to do the derivative of the inside. Now, it turns out in this case that this is another chain rule because I have something other than just x there. So this is going to be e to the 2x times the derivative of what's up top, which is 2. So there is the derivative of that function. Okay, so let's do this. I'm going to give you one here that I want you to practice. You're going to pause it, the video, and try this one, and then we'll work it together. Okay, so here's the function. F of x equals the natural log of x squared plus 3x minus 1. All right, so pause the video and try that one. Okay, so again, we have a composition of functions. This polynomial is being used as the input into natural log. So we're going to use the chain rule. And the chain rule says, okay, we take the derivative of the outside. So the derivative of natural log is 1 over, and then we leave this alone. So this will be x squared plus 3x minus 1. And then times the derivative of what's up top, which is 2x plus 3. So we would probably write this as 2x plus 3 over x squared plus 3x minus 1. Now, be careful to note that every once in a while on these natural log ones, you might be able to cancel something out. In this case, we can't. Okay, good. Let's try one more. This one will be a little bit more involved here. So f of x equal, let's try this here, the square root of secant of x squared plus sine squared of x. All right, so pause the video and give that one a shot. All right, so once again, we do have a composition here. We have an inside function, secant of x squared plus sine squared of x, and it's put into another function, and that is the square root. Okay, now keep in mind that we would want to think about the square root as something raised to the 1/2. So if we rewrite this, we can say that this is equal to secant of x squared plus sine squared of x, all raised to the 1/2. Okay. Now, so when we do the derivative, we're going to do the derivative of the outside. So this is a power rule. So we're going to bring the 1/2 down here. And again, keep in mind, we're going to leave this alone. So this is going to be secant of x squared plus sine squared of x raised to the negative 1/2. And now I need to multiply it by the derivative of what's inside. Now, the derivative of secant is, now again, this is a chain rule again. So I have a chain rule here because I have an inside function, and that's used as a composition in the secant. So I'm going to have the derivative of the outside, which is secant. So that's going to be secant of x squared tangent of x squared. Note, I leave it as x squared in there, times the derivative of what's inside, 2x, plus, now, this one is an interesting one here because really this is sine of x all squared. So we're going to use the power rule. We're going to bring that 2 down in front, leave this as sine of x raised to the 1 power. You don't have to write it, but I'll go ahead and write it. Times the derivative of what's inside, which is cosine of x. So if we were to write this, you know, more succinctly, this negative 1/2 puts this in the denominator. So I would have on the bottom, I would have a 2 and then radical secant of x squared plus sine squared of x. And on the top, I'd have all this. Now notice I can factor out a 2. There's a 2 in this one, and there's a 2 in this one. So I'm going to go ahead and factor out that 2. And then I will have x secant of x squared tangent of x squared plus sine x times cosine x. And now this 2 and that 2 would cancel out, and that's what you would have as your answer. All right.